In exercise 2221, they're giving you the product of an aldol condensation, and they're asking you what would the original two molecules have had to look like to make this. And so you'll remember that what you get when you do an aldol condensation is an alpha-beta unsaturated aldehyde or ketone. So you have your carbonyl carbon, the one next to it is your alpha carbon, and then the next one along the chain is your beta carbon. So you have an unsaturation, or a pi bond, between the alpha and the beta carbons. When you're trying to figure out what two molecules came together in this condensation, what you want to do is separate the parts of the molecule that are on each side of that alpha-beta unsaturation. So for example, on the left side we have 3 carbons, and so that's these 3. On the right side we have a sort of 3-carbon aldehyde. So if you're sort of labeling it with colors, that's on the right side of that bond, and on the left side we have these 3 carbons here. Now one of these molecules, one of these pieces will have a carbonyl already. The one that doesn't is the one that you're going to add a carbonyl onto, and you will add it where the original double bond was. So you could have that. Now when you draw that in, you'll notice that these molecules are actually the same. They are both propanals. And so the only molecule you really need in order to make this product is propanal, and it would just have to be present with some catalytic base, and also some water and some heat in order to do the condensation. This first part will do the aldol addition, the second part will do the condensation. And so if you have this recipe all together, that will give you your product. Let's try that out with a couple more. So here we have, and this is a good opportunity to show you an abbreviation. CHO is the abbreviation for an aldehyde. So that's this carbon double bonded to oxygen, single bonded to hydrogen. That's a CHO. Sort of like a carboxylic acid. Sorry, that's like CHO. Sort of like a carboxylic acid is sometimes abbreviated as COOH. So they're good abbreviations to know. Sometimes standardized tests will expect you to be able to recognize those. So this here is really, and let me just sort of draw over it with what it really is. You would have the carbon there, and then an H. So that CHO would really look like that. So what you want to do is sort of draw a squiggly line through the alpha-beta unsaturated bond. Remember, the carbon next to the carbonyl carbon is the alpha carbon, the next one down is the beta carbon. So draw a little bond on that side, and then what you want to do is copy the 2 molecules on each side of that squiggly bond. So you have this benzene ring with 2 carbons, and then the aldehyde. That's this molecule here. And then copy on the other side, we'd have the benzene ring with 2 carbons. So that's what we have there. Now, one of these has a carbonyl already. The one that doesn't is the one that you want to draw the carbonyl on, and the carbonyl will go where the double bond was. And notice this is still needing a bond there, and so it's to an implied hydrogen. And you'll notice these are both the same molecule. Both the purple and the blue are the same molecule here. They just came together in the condensation reaction. If you had this benzene ring with 2 carbons on it, and the aldehyde on the second carbon, and you treated that with sodium hydroxide and water and heat, then they would come together, you'd get an aldol addition, and then when you heated them up, they would undergo the condensation. You do the elimination, get the alpha-beta unsaturated pi bond. Okay, let's try it one more time with C. So what you want to do is look for the alpha-beta unsaturation. You have your carbonyl carbon, next to that is your alpha carbon, and then one more down, that's the beta carbon. So draw a squiggly line through that unsaturation. We're going to draw each part of the molecule on either side of that separately. So on the left side, we'll have this aldehyde. On the right side, we'll have 1, 2, 3, 4 carbons here, and one of these has a carbonyl, the other one does not. The one that does not is the one we're going to add the carbonyl to, and we'll add it at the position where the double bond was. And notice that still needs that one other bond to the hydrogen, the implied bond to the hydrogen. Notice that these are both butanals, right? They both have 4 carbons, so bute, and they are both aldehydes. So they have, oops, 4 carbons, so bute, and they're both aldehydes, so al. So they're both butanals. If you take a butanal and you treated it with sodium hydroxide, water, and some heat, these first two would make an aldol addition reaction happen. The sodium hydroxide would steal an alpha hydrogen, turn that into a nucleophile. That would attack the carbonyl carbon on a second version of itself. You'd get the aldol addition product after these two, and then you heat that up, and the beta hydroxy group will be eliminated, and you'll form the pi bond. And you would get this beautiful product there. So this is some practice thinking backwards. Whenever you see alpha-beta unsaturated aldehydes or ketones now, keep in mind you can make them from just simple aldehydes. And we'll see a further complication of that, or a further variation on that in the next video.